Hi, friends. Welcome to Unit 1, Lesson 6. We're working on place values in scientific notation. Scientific notation is defined as writing numbers using a number between 1 and 10 along with a power of 10. So it's a way that we write numbers. One through 10, along with a power of 10. So you have to know, to be able to do this, you have to know what an exponent is, and you have to know what a base is. So let's start there. All right. A power of something is the same thing as saying an exponent. An exponent. When we write things with an exponent, it might look like this. So here's a number to the power of 3. So this number right here is the base number. And this number right here is the exponent. What 2 to the third power actually means is 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 2 to the third power equals 8. The exponent tells you how many times you're going to multiply this number by itself. So here we have 1, 2, 3 times. Our exponent was 3, therefore we multiplied the base number 2 by itself 3 times. I think it's important to know that before you move on to the next step. So place value charts are still a great tool for you to use even when you're utilizing exponents. Scientific notation helps you make a really big number a little bit easier to work with. So your curriculum gives you the number 2, 7, 4, 1, 9, 6, 8, 3, 5. 1, 2, 3, comma, 1, 2, 3, comma. There's our families, right? And then they give you a place value chart. Now keep in mind at this point, it doesn't show decimals. We're just looking at whole numbers, but we will get into decimals in just a few minutes. So this is the ones, the tens, the hundreds, the thousands, the 10,000s, and the 100,000s. Then we go into the millions. Again, repeating pattern, we have the 10 millions and the 100 millions. We read this number 274,196,835. Very large numbers like this can be written using scientific notation. Here are the 3 steps to follow when writing in scientific notation. Step number 1. Place a decimal point between the first and second digit in the number. So this is going to be between the largest place value. Remember, this is our place value and these are our digits. So it's going to be between the first and second digit in the number, or between the two largest place values. So let me write that down. Place a decimal point between the first and second digits. All right. So let's look at it this way. It's going to be, here's our example. Okay, for step 1, our first and second digits are these two numbers right here. Those are also in the largest place value, so we're going to put a decimal point between the first and second digits. 2.74196835. Whew, that's still a lot, right? The second step is going to be to place a times 10 after that number. 10 is going to be our base, and we're going to have an exponent that goes with this in just a moment. So you're going to place a times 10 after your number. So this number that we just created, this 2.74196835, is now 2.74196835 times 10. Now, again, this is our base. We're not finished yet because this is not the same thing as 274 million. This would only be 27 and 41,968,000. Sorry, let me try that again. 27 and 4,196,835 10 millionths. Took me a minute. All right, so we have to move on to step 3. Step 3 says, write a number to the right and above. We're going to write an exponent. On the 10 that equals the number of digits from the end of the number to the decimal point. All right, so if we have 2.74196835 times 10, we have to count 1, 2, 3, 4, 5, 6, 7, 8 moves. So we're going to make our exponent 8. So in scientific notation, 274,196,835 is written as 2.74196835 times 10 to the 8th, because we moved the decimal 8 places. Do you see that? 1, 2, 3, 4, 5, 6, 7, 7, 8. We moved it 8 places. Each one of those is times 10. So every time we multiply by 10, we can move the decimal one place to the right. All right. Tune in for more practice.